Just one glance at the countless formations in the firmament shows the dimensions of the universe far exceed our imagination. When we consider that our view of the stars covers only a tiny fraction of the entire universe, it becomes clear that we are still far from having unlocked all the secrets of our galactic neighborhood. In addition to the exploration of already known celestial bodies, the search for previously undiscovered planets is one of the most important fields of modern space research. The main focus of scientific interest is on those objects that are most similar to our Earth in terms of their composition. The search for potentially habitable planets has kept the scientific community on tenterhooks for several decades. A recent discovery by NASA leads now to the fact that the list of Earth-similar celestial bodies has been supplemented by a further unusual representative. While planets in our immediate galactic neighborhood have been known to us for many decades, beyond our solar system, there are still countless celestial bodies whose existence we know nothing about. Until recently, these included the exoplanet TOI 1231b, which made scientific headlines due to its unusual atmosphere. NASA employees at the Jet Propulsion Laboratory in the U.S. state of New Mexico were responsible for the discovery of this celestial body. The experts succeeded in locating the fascinating object at a distance of about 90 light-years in the night sky. The exoplanet orbits a red dwarf, one of the smallest stellar representatives in the universe. Scientists quickly realized that the newly discovered planet has some striking similarities to our terrestrial home. The celestial body needs only 24 days to orbit its host star once. Regarding its average surface temperatures, TOI 1231b can be confidently classified as Earth-similar. The average surface temperature is 134 degrees Fahrenheit, making it one of the coolest known exoplanets. Comparable transit planets show, in most cases, scorching hot surface temperatures exceeding several hundred or even thousands of degrees. Experts also assume that there are clouds in the atmosphere of the planet. According to initial findings, the object's natural protective shell is composed of hydrogen. At the same time, the research results give an indication that the surface of the celestial body could be adorned by liquid water. While these early findings give rise to sensational conjectures, future investigations are needed to fully fathom the nature and precise characteristics of the fascinating exoplanet. When it comes to the question of Earth-like celestial bodies, there is no way around Kepler 452b. The planet owes its name to the Kepler Space Telescope, which helped to identify the object. The host star that Kepler 452b orbits is located about 1,800 light-years from our Sun. In fact, the two gleaming bright celestial bodies show fascinating parallels. The remote star is only 10% larger than our Sun. The exoplanet itself, however, easily dwarfs our Earth in terms of its dimensions. According to current estimates, the diameter of the exoplanet is up to 80% larger than the diameter of the Earth. To circle its central galactic fixed point once, Kepler 452b needs about 385 days. Since the celestial body is located in the habitable zone of its planetary system, it's considered a promising candidate for the hypothetical existence of extraterrestrial life forms. About 4 years ago, renowned scientists made a sensational announcement: the discovery of the TRAPPIST-1 planetary system. According to their findings, at least 7 Earth-like exoplanets orbit the red dwarf that gives the system its name. The experts came to this conclusion when they noticed that the brightness of the low-mass celestial body decreases at regular intervals. This fact, in turn, indicates that several objects must repeatedly pass by TRAPPIST-1. Of all the known celestial bodies in the TRAPPIST-1 system, the planet TRAPPIST-1d is one of the most exciting. In all likelihood, the object 40 light-years away from us is a rocky exoplanet that lies in the habitable zone of its galactic association. To orbit its central star once, TRAPPIST-1d needs just a little more than 4 days. Regarding its size, the exoplanet appears to be somewhat smaller than our Earth. It's probable that TRAPPIST-1d, like all other representatives of this planetary system, is tidally locked. This means that one side of the celestial body is always illuminated by light, while the opposite area is permanently turned away from the host star. Some evidence suggests that a vast ocean of liquid water once existed on TRAPPIST-1d. Presumably, however, most of this galactic sea evaporated over the millennia. Nevertheless, it's possible that at least a small part of the water defied the ravages of time and is still present on the planet today. However, nothing is known about the exact chemical composition and the hypothetical atmosphere of the celestial body. When we travel 4.2 light-years into space from our Earth, we encounter the star Proxima Centauri. In fact, this celestial body, located in the constellation Centaurus, is the closest star to our Sun. However, if you want to observe this fascinating object from our latitudes, you'll be hard-pressed to do so due to its location. Proxima Centauri can only be seen from earthly locations below the 27th parallel. As we know today, the red dwarf is not alone in its galactic orbits around Alpha Centauri A and Alpha Centauri B. Using the radial velocity method, scientists succeeded in the summer of 2016 in providing evidence for the existence of the exoplanet Proxima b. The spatial constellation between the celestial body and its central star, in turn, gives rise to the assumption that water could exist on the planet in a permanently liquid form. Since Proxima b is the closest known exoplanet to Earth, its detailed investigation is comparatively simple compared to other, more distant objects. The mass of the planet is estimated to be between 1.2 and 3 Earth masses. Based on the luminosity of the host star, the spatial position, and the estimated albedo, experts were able to estimate the average surface temperature on Proxima b at a value of -38 degrees Fahrenheit. Should the Earth-like exoplanet have an atmosphere, however, this could lead to a greenhouse effect on the celestial body, which would eventually result in significantly higher temperatures. Thus, as already briefly mentioned, the existence of liquid water would also be possible, which is known to be a basic prerequisite for the emergence of life. In the Aquarius constellation, approximately 228 light-years away from our blue homeland, lies the planetary system K2-72. In addition to the red dwarf of the same name, this galactic group also includes 4 planets. The outermost of these, K2-72e, often finds itself at the center of scientific interest. The confirmed exoplanet K2-72e, which was added to stellar maps with the help of the transit method, has a radius that is about 0.86 times that of Earth. At the same time, K2-72e experiences average temperatures that hover around 61 degrees Fahrenheit. This makes the exoplanet an intriguing candidate for habitability. The orbital period of this exoplanet, located in the habitable zone, is just 24 days. However, its rotation is tidally locked, meaning one side of the celestial body is permanently facing its host star while the opposite side remains in perpetual darkness. This unique characteristic creates a narrow, twilight zone where conditions might allow for the presence of liquid water. Despite this potential, it remains uncertain whether life could truly develop on the planet. One significant factor that could hinder habitability is the high level of stellar radiation from its central star. This intense radiation might lead to the evaporation of any water deposits on the planet's surface. Future research will be needed to determine whether K2-72e holds the potential for life or whether it is an inhospitable world. Finally, we would like to remind you that it's not absolutely necessary to travel to distant planetary systems to find celestial bodies on which life forms could develop. Even Saturn's bright moon, Enceladus, has long been suspected of being a suitable candidate for the presence of extraterrestrial life forms. A first look at the ring planet's icy companion might make this theory seem implausible. The surface of Saturn's moon is buried under an impenetrable, mile-thick layer of ice. Its natural shape and position in relation to the Sun mean that Enceladus experiences freezing cold average temperatures of -328 degrees Fahrenheit. If life does exist on this celestial body, it would likely be found not on the surface, but in the deeper subsurface regions. Enceladus is thought to harbor a gigantic subterranean ocean beneath its icy crust. In addition, the moon is known for its countless cryovolcanic formations, which regularly eject massive fountains of water vapor and other materials into space. Detailed studies of these emissions have revealed the presence of methane, a chemical element that could hint at the existence of tiny microbial life forms. One hypothesis suggests that these microbes might thrive in hydrothermal vents at the bottom of the Moon's subglacial ocean. Alternatively, the methane could be produced by as yet unknown geological or chemical processes. We're already looking forward to your comments. Please also take a moment to explore the other exciting videos available on our channel, Digital Discoveries, by clicking on the images in the credits. Thanks for watching, and we'll see you next time.